This is code.org, and we're almost ready for our performance task. Exciting. The great thing is we can prepare for our performance task. Of course, the app itself and the project is completely on our own, but code.org provides us a ton of resources to prepare to do well. So here's one of those apps that we had worked on earlier, and I want to take a look at just how we can make sure to knock this out of the park. So here's the review material that they give us, create a PT prep, right? And your material could look like this. It could also look like this. Either one is great. So either it would look like this in this order. It's the same material. Now what I've pulled up is, and what we're going to look at is their sample 1, and then their writing sample annotated code.org sample 1, and it's on both. So the reason we are looking at this is it was their perfect scoring app. So let's first play the video that they provide. And notice that the video demonstrates input, because that's definitely what you want to do as a student. And by input, I mean changing. So if you have a text box, you want to be typing something. If you have several buttons, you want to be clicking them. You want to show several different forms of ways the user can input information into the app, and you need to see the response. You need to see output by the application. Input and output. Make sure your video is under a minute, and it needs to be under 30 megabytes. So under 30 megabytes. And if you use something like Screencast-O-Matic, that will be easy peasy. Look how small this video is. Okay, so input and output, short and sweet. All right, now with that said, let's take a look at the next part. Well, let's take a look at the app itself. If you're wondering where I found this, it is part of Unit 7, Parameters, Return Type, and Libraries. We did work on this, right? It's Lesson 2, it's over here in one of these bubbles somewhere. And depending if you did the challenge or not, or the extra time, you might have a drop menu here, which is perfect, or you might have an input box. Either way, this is that perfect app they were demonstrating, and I'm not guessing that this got a great score. Code.org tells us, Code.org sample 1, score 6 out of 6. So let's see what it's doing and why it could have gotten that score. I'm going to take a look at the data. Now we have the words here, and what is this a table of? Okay, words, parts of speech, million, the length of the word, so on and so forth. Now what are we doing with that in this app? Line 1, we create a list, and we grab the words, and then what column? The word column. So that would make sense. We grab all those. Then what? Well, we're going to filter get number length A. Well, what would this be doing? This must be a function call. It's a green block, and we can see with the parentheses after it. So the computer is going to hit this and say, what the heck is filtered? Smack. Oh, this is what's going on. And it's going to run this code. Now for length and letter, these parameters, it's going to say, what's length? Oh yeah, length. Zoop. Oh, get number length drop down. So if I hit run right away, the length is 1. And so the length here would be 1 when line 4 runs. The letter is A. And so it's going to go show element waiting. And we did see that briefly. Waiting image, show element unclickable. And it blocks us off from clicking. Look at this thing right there. That's what shows up. Set output text, it blanks the output area. And then what do? They do a for loop. So for var I is equal to 0, I must be less than the length of the word list, right? Then this whole list, I++. So I is going to start at 0, we'll add 1 to I each time, and we're going to stop counting up when our I is equal to the length of the word list, right? There would be no more words to take a look at. So everything in this blue mouth thing, or if you're in text mode, awesome, everything in these brackets, right, is going to be looped over. I starts at 0 because all indexes of a list start at 0. This might say 1 here, but the index is 0 for the. The index for B, this might say 2 because it's the second word. The index is 1, index 3, index 4, index 5, so on and so forth. So we always start counting at 0 when we mean indexes. Now if we have a list with 3 things in it, and I do dot length, just like we did here, dot length, that would give me, again, there's 3 things in my list for pretend, that would give me a 3. Dot length returns how many items are in the list. Now if I wanted to use those 3 things with a index, I would say 0, 1, and 2. There's no third thing. There are 3 items. There's no third index. That's why this works, by the way, because length will say 3, and then we start I at 0. Well, 0 was the, 1 I don't remember, and then 2 I don't remember, and then, oh yeah, length is now 3, we're done. So, that being said, if word 0.length is equal to length, and what was our length right now? It's equal to 1, and word I substring, so we're cutting up a string here, which is the word 0 to letter.length. Letter.length, what's that? Oh, weird. So letter.length is always going to be 1 if it's just one letter. What this lets us do, though, is if you changed it to an input area, we could put in multiple letters. But so it's going to be 0 to 1, essentially. So just that first letter, or multiple. And if that's equal to letter, so what did I just say? Okay, the length has to be equal, whatever length I passed in here, which is whatever length they have here, it grabs that, and the letter has to be equal. We default it to A. If those two things are equal, well then we append, we add, append means add to a filtered word list, which is empty by the way, the word list.I. So we smack that word we just found that meets the 2 criteria into this filtered word list. And then we hit the bottom and go zoop back to the top. Now we say, okay, I was just equal to 0, I plus plus, because that means I equals I plus 1. So 0 plus 1 is 1. 1 is still less than the length of our list. I'm just going to pretend like it's 3 still. And so word list.1, and what would 1 be in our data? Would be the word B, because it's index 1, is B dot length equal to 1, because they defaulted to 1 here. No, right? B is 2. So this is already false. Zoop, we drop below the if, hit the top, zoop. Now let's say that our final word, I plus plus, so I was equal to 1. 1 plus 1 is now equal to 2. 2 will be less than the length of our list. We drop down. And let's say that the word at index 2, even though right now it is and, we're going to pretend like it's A. So it's going to say, is A length 1, because 1, true. And is the substring 0 to 1, which is just the first character. Okay, 0 to 1 would be first character. 0 to length is however many letters I put in here, but is it equal to the letter entered? A. Well, if the word's A, this is true. And again, we'd smack it on to the end of our list. Hit the bottom back to the top. If our list was only 3 long, well, our number was just 2. 2 plus 2 plus 1 equals 3. 3 is not less than 3 if that's the whole list, and we're done. Now let's take a look here. We have another conditional. Filter word list.length is equal to 0. So if we just went through all of this, and this filtered word list is 0, that would mean, oh, we must never have found a word that is the length that they entered, and that is the letter that they entered it to start with. So this was never true. We never found a word that matched that. So if we have a length of 0 for our filtered list, no word found, we want to push into that filtered list, no options available, to let them know, yep, nothing there. Now we're going to hide that waiting image. We're going to hide the unclickable element so they can't use these. And then we're going to set the text output. What's output? Oh, look, it's this text area to the filtered word list, and join just smacks it together. So we grab every item in the list and put a comma after it if there's multiple, right? And that's why if I do 5 and starting with A, boom, that's where our commas come from. Okay, then we hit the bottom of our function and we go back up to where it started. And so we called it here, and that's just what makes it run automatically right away. Okay, well now we're done with that. Now on the event that they do change the length, this is going to run. So if I change this to 3, boom, this is going to run. It's going to filter list, get number, I have a new number, 3, get letter to lowercase. So I'm making sure that if they type in something else, it would still be lowercase. So get that text, and then it runs all this again. So if they change the letter like I just did, same deal, it's going to grab the number, grab the letter, and run it all again. And again, this is their example. They had the drop down, but it would work the same, of their high scoring app. A drop down, you could just use 0 to 1 here instead of letter length, because you know they're only going to be having one letter. Other than that, pretty much the same. So now that we have a good idea of what is inside of this application, let's take a look at their written response. Why not use this example that they're providing us? So they provided their written response in this format, but I'm much more interested in looking at it like this because we can go over the requirements that you want to make sure to cover to knock this grade or this score out of the park. So let's scroll down. This is really useful. You do want to double check this. Oh, your file size for your video cannot exceed 30. Keep that in mind. 30 for your video. Okay. Describe the overall purpose of the program. Describe what functionality the video illustrates. This is key, guys. So you need to tell them, hey, what's going on? What's the program do? What is it accomplishing? Describe what functionality the video illustrates. So tell them literally what's going on in your video. And describe the input and output shown in the video. Okay, well, here's their response. So this is their example. They gave us a little screenshot here to help us understand. The purpose of the word game helper app is to assist users in finding words to help in various games like Scrabble or crossword puzzles. Now, you just need to make sure that you are clear. Do not create some magical, they didn't say, is to create complex new words from blah, blah, blah. No. Tell them what it does. So if for some reason your app only finds words or school names with states, well, why would someone use that? And you don't want to just put like, oh, well, they could have a state entered and it will show them the school. You could put something like, you describe what it does, but just point out a bit of a benefit, right? You don't have to go too far out there. The user can enter a state and it will show them the available schools in case they forgot. If they're interested in sports, what's some of these benefits that you can tack on? Just don't go way out in left field. The video shows how the user selects the length of the word and the first letter. Literally describe what you are showing in the video. If you're not showing that in the video, 1, maybe you should think about showing it if you want to write about it. 2, make sure you're showing it in the video. So tell them what it's doing. And now, why would that matter? Because then you're going to explain the input. So here, the user inputs a value to the program using the dropdowns. You might have a text box. Maybe all of your inputs buttons. I don't know, maybe you have a button 1, 2, 3, and that's how they select the size. You need to explain how the user is interacting, giving the application information. You want to say something like the user inputs, or data is input into the app. If you're not writing about how input happens, yikes. All right? Dropdowns. The output, which is a list of words, it's very likely that your output's also going to be some list of words, okay? It could also just be one word if, for instance, you're looking for the largest or smallest of something, or one number in that case. But you want to know the output is what you are going to push out, pop onto that screen once the user has interacted with the application. All right, which is a list of words that meet the chosen conditions. Don't let this scare you. What they're saying there is that it meets the if statements, right? So the output must meet the conditions. And yours better have a condition. So you could say the output matches what the users entered. The output is provided or pushed out to the screen after filtered with an if statement. Right? I would use the word condition because condition's the fancy technical term, but you want to point out in some way somewhere in here that that is the case, that your output is going through some form of a condition. You also want to use your own words. So if you're like scribbling this down to memorize it, no, okay? Make sure you're using your own words, but this is an awesome example. The response earned the point for this row. The response describes the purpose of the app directly, right? Literally, this is what it does. Input, output are shown in the video. Make sure to do the in the response, drop downs, list of words, and what's being displayed. All right, let's take a look at this next portion. So the student response here, and again, they provide us some screenshots, which is super helpful. All right, for this, capture and paste 2 program segments you developed during the administration of this task, which contain a list or other collection of data being used in your program. The first program code segment must show how that data has been stored in the list. Boom, right? So somewhere in your program, you better have a list. A really easy way to know it's a list is if you are using get column, right? Like we did here, like they did here, right? This is coming from their data set. I know that's a list. Another way to know this is a list is these 2 square brackets. This is an empty list, but it's a list. Okay, so the first program code segment must show how the data has been stored in the list. And so if that was an empty list, It's not really storing anything yet. Keep that in mind. You really want to do the list that stores data. The second program code segment must show the data in the same list being processed. So how is it manipulated? Are you looping through looking for biggest? Are you looping through looking for a state? You want to show how that list is being used. So here's the name of their list. You would look through the program for that name again and know that's where you're using it, whatever your list is named. All right, so let's see this great answer that we got. On line 1, a list called word list collects all of the words from the words database and stores them as a list. That seems redundant, but it's very straightforward. It shows them you know what you're doing. So for you, maybe you have a comment on line 1, but regardless, you want to say, hey, my state list contains all of the states. The data is taken from the data set the column of states, and stores them in my variable named. Something like this. You want to just be really direct about it. Each word is stored as a string. Don't let these words scare you. They're technical and they're good to use because it shows them you know what's going on. A string is just a word. So anything with quotes around it, basically, that's a variable or in a list, like this, boom, that's considered a string in code. A sentence can also be a string, by the way, right? If it has quotes around it, that is going to be a string. A number can even be a string if the number is in quotes itself. That's considered a string as well. So you'll know by quotes. Your data also might just be numbers, so an integer. If it has a decimal, though, it could be considered a double or a float, right? Using those technical words is a good idea. So our data for this one is a string. The word list is used in the program to show users suggested words of various lengths starting with a given letter. This is directly stating, okay, how am I using up my list? Oh, I'm showing words based on what? Well, the length they input, so based on lengths and based on the letter. So what are you considering for your output? That's what they're doing right here. Okay, words, what's being considered? Length and letter. For example, if the user, perfect. If you're not saying for example, yikes. And notice the example they're about to talk about is in their video because it shows a really clear line of thought and of planning. So that's a great idea. For example, if the user selects a length of 2 and the letter B, the filter function is called in which the word list is transversed. Now, shockingly, this is like I do. You go through and explain it, right? Because if you understand something, you can explain how it is working. You can teach it a bit. Don't let this word transverse scare you. Transverse means to move through data. So you could transverse a list if you are looping through that list, right? You could transverse a dangerous cliff if you are going up and around and through the cliff, right? But transverse data, transverse is a great word to use. You could also say iterate over. Iterate means to count up over. So in a for loop, you iterate. And so you can iterate through a list. That's another fancy word. Every element that is a length of 2, and again, they're literally explaining exactly what's happening. So if I have a 2 here, what's happening? Well, every element in my list, every part at each index, right, that is a length of 2 and starts with B, so this is the if statement they're explaining right here, they're conditional, is added to a new list. So make sure to explain, if you're adding it to a list, why? How is that happening? Well, they're choosing it by the length and the letter B. If you're looking for biggest, the element with the largest amount is saved in highest value. If another element, right, make sure you explain this. This list is what's outputted to the user. Yep, and you want to clarify when that gets pushed out or if that's what the user sees. The word list manages complexity. So what are they doing here? Well, this part, they identified what it contained. Explain how the selected list manages complexity in your program. And look, they're using the question in their answer. Perfect. These are habits you should already have in your program code by explaining how your program code would be written differently without using the list. The word list manages complexity because it allows any number of words to be stored in the list. Yet think how difficult, frustrating, labor-intensive it would be if you need a variable for everything, instead of using individual variables for each word. So your project, of course, will be different than this, but that's going to be universally applicable almost. As long as you have a list, if you're saving something or inputting data or appending data to that list, wow, that is so much easier than creating 30 variables just to save or 50 variables to save states' names. So that's a great idea to write, which would then be checked one by one to see if it is met. Yep, so it stores all of those original values to a list, and then this is again them hitting the conditional, the if, checked one by one to see if the requirements are met. That's their if statement. The program would extend from 32 lines long to thousands long to account for all these extra variables. Yeah, right? So mine, I guess, was 34 because I added a bit, but it would have to be so much longer because we couldn't use a list. I would have to say, if I had to individually look at all of these words, maybe the variable for and would be word and, right? Or and word any. And so I would have lines all the way down to individually look at each because I couldn't use a loop to go through an entire list. And so they're talking about what the application would look like without the list. What are the consequences? How does it manage complexity? It makes it much more simple, right? Because you don't have a bazillion variables. If words are added or removed to a data set, this list pulls from nothing. It will need to change about the code. The list allows the program to work for any number of words since the filter function will go through, will transverse all that data, since the filter function will allow iteration over the entire list of words no matter its length. So we can easily get through everything without a billion variables. You want to keep this in mind. Of course, all of your answers are in your own words, but they provide you examples for a reason. You really want to ponder them. And they're showing you, by the way, it's like a cheat sheet, guys. This is how the teacher's going to grade it. No award points if, bloop, there's no list, right? Because you gotta have to include a list regardless in some form. Does not name the list. Use of list is not irrelevant. They don't explain this why not applied to the selected list. Make sure you're going through these. They're highlighting stuff too. The response earned a point for this row, storing each word individually in its own variable. So you want to focus on that. How does a list manage complexity? Imagine the amount of variables, in your own words, of course, allows the program to work for any length of a word list. All right, let's see what else we have here. Capture and paste the procedure function from your program that you develop during the administration of this task, which implements an algorithm used in your program. The procedure function contain and use one or more parameters, arguments, parameters, that's the stuff next to a function. Don't let that word scare you. This is the parameters right here. Boom, length and letter. So my functions filter or procedures filter, length and letter, these variables are parameters. By the way, I think they say arguments in a second, or if they don't, we can use it anyways. Length is the parameter, letter is the parameter. When I ask this function to run here or here, get number length drop, that's an argument. The letter A here, that's an argument. So it's kind of confusing, but when you ask something to run, these are called arguments, and they fill in where the parameter is, right? Length is now equal to whatever that is. Letter is equal to A. So argument, argument, parameter, parameter. Okay, now, contain and use one or more parameters, implements an algorithm that includes sequencing, section, and iteration. Hey, I've used that word. Describe what the selected procedure does, how it contributes to the functionality, explain how the algorithm is implemented, select procedure accomplishes its task. So make sure you get your procedure in there, your function. The filter function is necessary in order for the program to output a filtered word list to users which meets their chosen requirements. So right away, they're hitting upon what does it do? What does their procedure do? And you want to make sure to state that for yours. Now they get specific by line. This is an excellent idea. It shows mastery of content on your part. So 16 to 30 show and hide an image to let the user know the program is still working. Interesting. So if you have a component like that, to filter the list, a for loop is used. Okay, so they want you to understand, and you should understand, a for loop loops through your data. So a for loop is used, line 20. Again, these specifics show me you know what you're talking about. Which transverse, that word again, we're not going to get rid of it. Transverse, to go through. If they're using this much in their example, guys, their 100% awesome example, I would recommend knowing what transverse is. It's to go through a set of data piece by piece. So they're going to transverse. The if statement on line 21, again, use line numbers. It points out, what's going on. Checks to see if the element at the index is the required length and starts with the required letter. So this is hitting upon those parameters right here, length and letter, that are being used. And they're explaining the condition, the if statement that they're looking for. If it does not, the element is added. If it does, the element's added to the filtered list. So this is the mechanism of action. They're literally, like I've done in so many videos, walking you through the code. They're trying to almost teach it to you. And that's what you want to do in your answer. So when does it add something to your list? Okay? When does that happen? What has to happen for that to occur? You need the grader to understand that you get this. After the transverse, that word again, transversal of the list, after going through the whole list, you should use this. If the filtered word list is empty, so now they're explaining, okay, we got through that whole list, and they're literally just going to the next line. What would run next? And notice they're explaining it in order of execution. That also shows me you understand the concept. You're walking through it in order that it would run, right? You don't just say, and then for blah, 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 skip over this and then go back to it later. Order it runs. All right. Is empty, a string is added, and they're using terminology. A string, again, is a sentence or a word, no options available, in quotes, that's a string, is added to let users know there's no options available. All right, so what's added, what's the data, and then explain the purpose. Line 27, and again, lines, it shows mastery. Finally, in line 32, the filtered list, what type of list? Well, we just narrowed it down in filtered list, is displayed to the user. With all the elements joined, where they get that from, they're literally talking about what they do here. Join, that's smacking your entire list together, and it automatically they have a comma in here, so it's going to put a comma in a space that they have, with a comma in between each one. Okay, now let's see what was important. To output a filtered word list to users which meets their requirements. Yes, you are outputting data that matches conditional input, all right? And how do I know that they are using their parameters or their arguments? Well, they're using it for the condition. All right, let's keep going here. Provide a written response that, they have more. Filters list according to the length of a letter. Yeah, so it also does that. It explains the filtering process. Provide a written response that describes two calls to the selected procedure. A call is when you say the procedure, hint the function's name. So function on line 15 for me, filter length letter, this is me making the function. All of this makes it. This function will never ever, this procedure will never ever run unless it's called. So I've created this. Where is it called? Well, for me, that'd be line 4, line 7, and line 11. It's where you ask it to run. The computer says filter, what's that? Smack. And then it says length, what's that? Oh, the get number, the length drop down. Oh, and what's letter? Boom. This is a function call on line 4, or where I call the procedure to run, or ask the procedure to run. Line 4, line 7 is the same, and line 11. All right, so let's see what they have here. Describe two calls that we can do. Describe what conditions, what ifs, don't let that word scare you, is being tested by each call to the procedure, and identify the results of each. So what's being tested is most likely your parameter or your argument that's being passed, because that's how the user is interacting or editing what's going on in your program, right? When they get the number the user entered and the text they entered, that's what's being tested here. So whatever your parameters are is probably what's being tested. Now let's see what they start off with. An example, and look, I bet this is from their video. Let's suppose the user selects from the dropdown a length of 3 and the letter D. The arguments passed, so they're using this terminology. Again, these right here are parameters. When are they arguments? Here. Filtered, get number. This is an argument, and the argument, when filtered is run, length, will be equal to this argument. This length parameter will be equal to this argument. This letter parameter will be equal to the argument A. Argument, argument, parameter, parameter. And arguments are passed to parameters. So the argument passed through the filter function would be 3 and D. That was what the user entered in the for loop on line 21. There is an if statement which checks, so this conditional statement which checks each element of the word list, and you're explaining exactly what your program is doing. To see if it has a length of 3 and starts with the letter D. So they enter this, what's going on? Well, we're going to check every word, what it is doing. For example, again an example, The element contains dog is examined. So what they're doing now is they're getting nitty gritty. They're saying, let's give you a point on my actual list. Okay, well, in is in my list. Dog is in my list. And they're walking through how the program interacts with it. Dog is examined. The condition length of 3-letter D is met. Therefore, the code segment inside the if line 22 runs dog is added to the filter list. Why they're picking dog, guys, is they want to show one that appears on the screen. So they're explaining why this happens. So why does age appear on the screen? And they're walking them through step by step why age appears on the screen. They're saying, okay, well, the user, hint me, have A and 3. So my arguments would be 3 and A, and then the function's going to run, and that's why age would be appearing, because we loop through all the words, and when it hits age, that meets it. So you want to have an example like this. Now, the second example, maybe you do a different word with different parameters, letter C, 5. Or if you have a failsafe for in the case of an issue, like it doesn't find any, that's what they're explaining here. They explain their next conditional, which we've already talked about, their next if statement, which is right here, if filtered word list is 0. So if there's no words in this list, this is going to occur. And what this is checking is if all of this ran and found no words, we know nothing's available. So this would be true, and it adds no options to the list, and it would appear there. So they're walking them through the execution when that occurs, and that's going to be their 2 examples. No word is found with these conditions, therefore filtered, and notice the line numbers again. Highlighted stuff's important. 2 different calls to the procedure. Yep, there's 2 different ways we asked it to run. Here's what was passed, letter B and the number 1. So tell them what's being passed as arguments, and then tell them the resulting code. And keep in mind, they have to run different aspects of your program. So your 2 examples, there should be an if-else statement. That's the best way to do it. And those 2 examples that you give must be running different aspects of your program. We'll get into that more in a second. 2 examples are given different parameters. Yeah, so B or 5 and Q, 1 and A, those are different. Result in different segments of code running. Okay, and so this is critical. There's different segments of code running. If I provide 2 examples that are exclusively the same, so maybe Q and A or Q and 5 doesn't work unless something else is triggered. And in their program, it wouldn't be, right? Both of those are just the for loop. So make sure then to have some section of code that runs in the case of an issue, or that runs when data errors out, or in a particular circumstance. Maybe you want them to always have 19 letters, and you put that. I don't know what your app is, but you want to have, I would have a if statement outside of your for loop that does something, that changes the data in some way. That way you can make sure you have another if statement, another condition that is interacting and outputting information. And you need to explain how it is different. Okay, so results in different segments of code. So you need different segments. You can't do what I was saying, Q and A, because that different segment. The result of each call explain. Any word that has 3, D, yep, add it. No word is found with these conditions, so they explain and they highlight the lines what would happen. Code.org. While the student earned the point, we believe a strong case for the requirement that each call must pass a different argument, causing a different segment of code to execute, would be made if the code included an if-else statement. So what they're saying here is it could be a better idea would be to have an if-else. And the reason they're saying that is because the lines of an if-else statement can never run at the same time. So you are certain that you will have different results from it. So one way to do this is I could say filter length 0, right? And else, if it is not this, maybe I want to put in front of it something. So that way you know this will run sometimes, or this will run. And only one will run, because this has to be true and this happens. This has to be, if it's false, the else will run. And that makes sure that you do have a clear distinction. So if you have an if-else in your program, you have 100% something running differently, because a different interaction will occur because it's binary. True, this line runs. False, this line runs. That's one way to be certain that you have that requirement met. And so maybe down here, like I was just saying, maybe I remove, maybe I insert. So maybe if they have those requirements, my list name was filtered words, and then at index 0, I'm going to insert right at the beginning results. Boom. Okay, so let's see. And now results, comma, A. So I might do some editing here, but you get my point. That way we know there's execution of this or this, so you know you'll have a different part of the code running each time. All right, that's their example. Consider this carefully when you're making your incredible app. Also make sure it is your own content. Good luck. I bet you'll rock this.